Hey peeps, here we are again, still working on rational expressions, chapter 6. So this is going to be the recording for how to find the domain of a rational function. This is in 6.1. So we're going to start out with this rational function. So it's in function notation. Remember this f of x can be replaced with y, so we could say that y equals this. Now if we have this function, I could plug in any value that I want for x. I could say, well, what if x was 1? Well, if x was 1, I'd get 9 plus 5 over 2, which would be 14 over 2, which is 7. So if I were going to make a t-chart, and I would say this is x, and this is the f of x, which by the way is the same thing again as y. When x is substituted for the value of 1, then y is 7. And I could plug in 100 and get 905 over 2, which is going to give me 402.5. So when x is 100, y would be 402.5, and we could go on and on. I could plug in a negative 3, and I would get a negative 27 plus 5. All of these are over 2. And a negative 27 plus 5 is a negative 22. Divided by 2 is a negative 11. So when x is negative 3, we get negative 11. And I could plug something in here all day for x. It doesn't matter what it is. I can plug anything I want and I will get a value. There's nothing that I can't plug into this function that wouldn't spit out a corresponding y value. Okay, and that's because the variable is only in the numerator. But remember, we have this rule that keeps haunting us that anything divided by 0 is undefined, right? So if anything divided by 0 is undefined, then if I have a variable in the denominator, then I have to make sure that whatever I would plug in would not make the denominator 0 for a function. Okay, so let's look at this again and just review that anything divided by 0 is undefined. Okay, so if I have a function, say I have 5x squared minus 3 over x minus 1, and this is my function. So I can plug values in here all day. Again, I could plug 1 in for x, I could plug 2, 3, 4, 5, whatever. Plug anything in. But only when I plug in 1 for x, when I substitute 1 for x. 1 squared is 1 times 5 is 5. Minus 3 gives me 2. 1 minus 1 gives me 0. So you can see here that when x is 1, this function would be undefined. Okay, or this expression right here would be undefined. So the problem is that if the expression is undefined, then you cannot solve the equation. You can plug in any values you want. It just can't be the value that would make this 0. So here we would say that the domain is all real numbers. So we'd say x is such that x is all real numbers except for x cannot be 1, because when x is 1, the denominator is 0, and we cannot have the denominator 0. So this is how you would find the domain of a rational function. Let's go through one more example to show you how you would do that. Here we didn't have to factor it all. But let's look at a different example. So let's say this time instead that my function is 7x minus 2 over x squared minus 2x minus 15. Now what I want to do is I want to say, well, x can be anything except for what? It can't be whatever would make this denominator 0. Well, the way we're going to find how it would make the denominator 0 is by factoring. So I'm going to go through my steps of factoring, but I only care about the denominator. The numerator can be anything we want. We just can't have the denominator be 0. So I'm going to say, hey, there's no GCF here. There's 3 terms, and this coefficient is 1. So I'm just going to do hippo butts. So I've got an x here and an x here, and the factors of 5 are going to be 5 and 3. That's going to be a negative 5 and a positive 3. Those multiply to this negative 15 and sum to this negative 2. So the value that x can't be is not this 5. The value that x can't be is what you would plug in for x to make this factor 0. Because if x was 5, then this would be 0, and 0 times anything is 0. That would make this denominator 0 if x was 5. And if x was 3, or negative 3, if x was negative 3, then I would get negative 8 multiplied by 0. And this factor would be 0, which would give me 0. So again, the domain here would be that x is such that it's all real numbers, except for x cannot be 0, sorry, can't be negative 3, and it can't be 5. It can be 0. If I plug in 0, I'd get negative 15 in the denominator. It can't be negative 3, and it can't be 5. So this is how you find the domain of a function.